Hello, this lesson is for Unit 4 or Unit 3, Lesson 4 on multiplying monomials. So a monomial is just a polynomial that's one term. So it could represent just numbers, it could be just variables, or it could be a combination or products of numbers and variables. And they could have more than one variable and still be considered one term. When we multiply monomials, there's a rule that we can use with the exponents. As long as the base is the same that you're multiplying, and the base means this first value, so as long as this base matches this base, when you multiply, you add the exponents. So to multiply powers of the same base, add the exponents. So as an example, I'm multiplying 4 squared times 4 to the 5th. They both share a base of 4, so I can actually just add the exponents. So 4 to the 2 plus 5, this is equivalent to 4 to the 7th. And you could actually multiply that out to figure out what it actually equals as a number, but the bulk of this lesson will be with variables, so you can leave it as 4 to the 7th. The second example, I have an x squared times x to the 5th. This middle x doesn't have an exponent with it, but think of it as x to the first power. So now we're actually adding x squared plus the first power plus the 5th power. So when you actually multiply x squared times x to the 5th, you come up with x to the 8th by adding each exponent value that's listed. You can also multiply if there's coefficients on the outside. So in this case, we have a negative 4b cubed c squared times 7b c squared. For the numbers in front, the coefficients, negative 4 times 7 is 28. And then b cubed times b to the first, you add those exponents, so 3 plus 1 would make this b to the 4th. And then the last one, c squared times c squared, adding those exponents, 2 plus 2, you get c to the 4th. And then this would be your answer. You can't combine the exponents of these two because they're different bases. This last example, when it's written as a fraction, remember to multiply fractions, you multiply across. So in the numerator, 5 times 3, we end up with 15. X squared times x squared, you add those exponents, so x to the 4th. And then y squared times y, remember there's a 1 here, 2 plus 1, we end up with y cubed on the top. And then in our denominator, 2 times 7, we end up with 14. And this one actually cannot be reduced, so this would be our complete answer. But if it were a case where the fraction could be reduced, you want to make sure you factor out any common factors and simplify that fraction.